Plasma is a yellow-colored liquid component of blood that holds blood cells in suspension. It's 90% water and contains critical proteins. Companies harvest these proteins from donated plasma to manufacture medical treatments. Proteins from human plasma are used to treat shock, bleeding disorders, and immune deficiencies. First, the plasma is separated from the blood cells and placed in a freezer at a temperature of -4 degrees Fahrenheit. This process preserves it until scientists can test its quality. A computer monitors the temperature and prints out measurements so the team can ensure the plasma remains adequately frozen. Ready for production, the plasma goes from a freezer to a cooler and then a warming bath to thaw the outer layer. A machine collects the bottles and moves them into slots. A blade slices them open to release the plasma. The outer layer of plasma has liquefied, but the cores are still frozen. Then the plasma travels forward to a heated mixing tank. The agitator and heat break up the chunks and the plasma becomes liquid. Transferred to other tanks, technicians expose the plasma to conditions that cause the proteins to become insoluble. They're pressed into slabs. In this form, the proteins are known as precipitate. A technician scrapes the precipitate off the filter sheets and into a plastic-lined container. An automated system retrieves the filter sheets and takes them through wash stations to remove residual precipitate. Once thoroughly washed, the filter sheets are ready for the next filtration. A technician breaks the protein chunks into smaller pieces and bags them for freezing. This protein is called albumin. Albumin helps maintain and repair tissue growth. Next, technicians dissolve the albumin protein in water. They remove the precipitate from the freezer and pound the outside of the bag to further reduce the size of the pieces inside. Then, the bags of precipitate are emptied into the mixer, causing the particles to disperse. Over the next day and a half, processing continues to purify and concentrate the albumin. At the same time, glass bottles enter into a chamber with cameras to take pictures of each bottle. A computer locates defective bottles and signals a mechanism to knock them out of the line. The bottles cycle through a washing machine and then a hot tunnel for sterilization. They're now ready for the albumin protein. Needles inject the protein into the bottles, filling 8 bottles simultaneously. A robotic arm inserts stoppers in the necks of the bottles. Then a machine installs aluminum seals with flip caps. They crimp the seals around the necks for extra protection. Technicians load racks of the bottled albumin into a pasteurizer. The chamber fills with water heated to 140 degrees Fahrenheit. This kills any potential pathogens. The glass vials slowly spin by a magnifying glass as inspectors scrutinize them for cracks, missing stoppers, broken seals, and other defects. A technician takes out any product with visible flaws. As the remaining bottles continue down the line, an inspector examines them again, this time visually checking the volume of the albumin protein. At the next station, labels unwind and a camera takes a picture for a computer check of the batch information. The computer confirms that what's on the label is accurate. Next, specialists place a sample in a petri dish and incubate it for 14 days. If there are unwanted microorganisms in the batch, they'll grow, but if not, the protein therapy is cleared for use. This protein therapy is now ready for medical emergencies.